Welcome to this lecture on Git and teamwork. Just to note that this video builds on an earlier video that I recorded that covers basic Git. So if you're new to Git, it's going to be better to practice those individual skills, and then you'll use them when you do teamwork. Also, just a quick note, the demo in this lecture is a little bit complex, and I had to record it separately. So you'll see two different versions of me in this video. We're going to talk about how teams can collaborate using Git and GitHub. I'm going to demo 3 common team situations that you're likely to encounter during the semester. In the demo, I'm going to show 2 simulated users who I'm calling Joe Bloggs, Mary Smith. They're both me, really, but I've got 2 terminal windows open as well as GitHub so that you can see how the collaboration is working amongst these 3 different repos. In the first demo, these 2 team members are going to edit the same file, but not at the same time. And that works pretty smoothly. They're not going to run into any problems. In the second demo, the team will be working on the same file again, but this time concurrently. But because they're working on different parts of the same file, Git is able to handle that and automatically merge their edits together. So no big problems there. In the third demo, our team members are going to work on the same file at the same time, and now they're working on the same line in the same file. Git can't cope with this because it doesn't know which of the 2 edits you want to keep. And so it throws a conflict error message, and it forces the team members to have a conversation and work out which one they want to keep. That's one that you have to fix manually. Let's just note that there are many different Git workflows that teams can use. The one I'll be demoing in this video has been called the centralized workflow by the Atlassian company, who have a range of tutorials. There's also some information at the official Git documentation on distributed workflows. All right, let's do our demos. In this first demo, we'll see Joe and Mary set up their remote repo on GitHub, and both of the team members are going to then clone that repo to each of their local laptops. Then they'll get to work. Joe's going to make a file. He's going to commit that change and push that back to GitHub. Mary will then pull that committed work back to her laptop. And then Mary's going to do some work now that Joe's finished. Mary will commit that work and push it to GitHub. Then Joe will pull the new edits that Mary made. At the end of that timeline, the team are all in sync. They didn't have any problems. Let's see that demo now. So in the black-colored terminal, I'm pretending to be Joe Bloggs. In the blue-colored terminal, I'm pretending to be Mary Smith. In my web browser, at the bottom of the screen, I've logged into GitHub, and I'm going to set up a repository, and that's going to be the repository that all these team members are sharing. So to set up a repository, all I need to do, give it some kind of name. A student work will typically be private. Certainly your assessment work should always be private. And then that's all I need to do. I'm just going to click Create Repository. So every team member now needs to set up a local repo on their own laptop and connect it to this one. And here's how we do it. I'm going to get this string here, send this to every team member, and that'll help them to connect to it. So over on Joe's computer, he's going to say git clone, and type in that address. And Mary's going to do that too. Both of them are going to get a warning. They've cloned an empty repository, and that's totally fine. We're starting a brand new project here. There's no files or anything in it. Let's see what they've got. Both of these team members will find they've got a new folder. This is the folder currently empty, and this is where we're going to start doing our coding. Now, is it really empty? Not really. There's a hidden folder there. This .git folder, you've probably seen already when you're doing individual Git. This is where the local repository is stored on your laptop. Now, you should never need to look inside there, but you can if you want to learn more about Git. Mary's got the same situation here. We've got a repository sitting there in a hidden folder, and we're ready to go. Now, there's just a couple of things that I need to do here. You probably won't need to do to pretend that these are really 2 different Git users, even though it's really me. So it's time to start working for this team. So the team get together, and they agree Joe's going to do some work first. And the first thing that Joe wants to do is to start the web page index.html. To make it quick, I'm going to use the Emmet shortcut. So I just did the exclamation mark and tab. It's our group project. So he's given the web page a title. If we say git status now on Joe's machine, he's got one untracked file. Let's say Joe's finished his work. He's got a parcel of work. He thinks it's ready to do a commit. So he's going to add all the untracked files and put in a commit message. Now we've got git log with a commit in it. All right, is Mary seeing that yet? In order for Joe's fellow team members to see the work that he's done, he needs to not just commit, but also push that commit to the remote repo. And then the other team members have got to pull the commit to their local machines. So I've got these two new commands, push and pull. Let's try doing that here. So Joe has pushed his first commit now to the remote repo. Let's click on that remote repo in GitHub. So the Our Group project repo has got one commit in it now. There's one file in that commit called index.html. You can see the commit message there. It's coming from Joseph Blogs. What about Mary? Is she seeing it yet? Mary still has no files. Mary needs to pull the work from GitHub to her local laptop. When Mary looks in her working directory now, she sees Joe's work sitting there, index.html. Let Mary open up that file in her favorite editor, which happens to be gedit. And the reason I'm using gedit here is because I just want the editor to look different from Joe's editor. But what Mary's going to do is make some changes in this code. She's just added a bit of text to that paragraph that Joe created before. At this point in her Git history, she still has the one commit that Joe's got and is up on the remote repo. But if she does a git status, she's got uncommitted work here. So Mary decides she's done enough work now. She's ready to share that work with her team members. So she needs to do two things. First of all, make a new commit. We can see, yep, we've still got that same commit that Joe made before, but now we've added a new commit. Joe looks at his machine. He still only sees that one commit that he already made. He's not yet seeing Mary's work. And likewise, if we were to refresh in GitHub, GitHub doesn't know about Mary's new commit. What does Mary need to do? We've seen this already. She needs to do a push. And if we refresh now we see that the latest commit in our remote repo is this same commit that Mary just did. We can click in here if we want and see the details of the commit. We can see the changes that she made. We can see the ID of the commit ID. We'll see, so it's the one that begins 08A1. We can see that sitting there. All right, there's new work. Everybody get it onto your own laptop. They say git pull. You can see the changes that are made. So there's one file change with some insertions and deletions. I just clicked into VS Code, and VS Code automatically refreshed. And now Joe is looking at the new work that Mary made. Okay, let's just recap what we saw in that demo. First of all, our team members, Joe and Mary, set up their remote repo. And I've got a 0 there because they've done no work. There are 0 commits at this point in the timeline. Joe and Mary then both cloned that repo to their local laptops. Joe did some work and made the first commit. He pushed that commit to GitHub. Mary then pulled that committed work to her laptop. So now the team are in sync. Mary did some work and made commit number 2. She pushed that to GitHub. Joe pulled that work to his laptop. Now the team are in sync again. These two blue lines show the periods of time during which Joe and Mary were editing that file. And they don't overlap, so they're not going to run into any synchronization problems here. In the second demo, Mary's going to go back and edit that file again, and so's Joe. And now they're both working concurrently. Mary's going to commit her work and push that to GitHub. Joe's going to try to commit that work, and GitHub will throw an error and say, no, I can't take that work from you until you've downloaded the work that your other teammates have already got here. So Joe will then pull Mary's most recent edits. They'll be merged automatically with the work that he's been doing. That'll create a new merge commit, which Joe will then push back to GitHub, no problems. Mary will pull that to her laptop, no problems. And again, the team are in sync. Let's see the demo now. So what we're going to do is Joe is going to add a new paragraph, and Mary's going to do some work too. They've both made changes in the same file, but they're making the changes in different parts of the file. So Joe's added a new paragraph in the body. Mary has changed the title of the web page. So Mary decides that she's done enough work. She does a git status. and she decides to commit all the work that she's done. Joe is also going to commit. Okay, what Git log do these two users see? Joe now sees 3 commits. Mary also sees 3 commits. But notice that the first 2 commits are the same. Joe has gone in one direction and added a new commit. And Mary's gone in a different direction and added a new commit. There's actually a branch here. It wasn't manually set up by using a branch command, but just by their actions of working simultaneously on the same file, they have set up a branch like this. What happens now depends on which team member pushes first. So let's say that Mary pushes first. No problems, that works fine. Joe's been doing some work too. He wants to share his work with his teammates, so he says git push. Joe gets an error message. You've got to download Mary's work onto your computer and incorporate it onto your computer, and then we'll add your commit. Joe can just say git pull. So before Joe proceeds, he's presented in his default word processor a commit message. We'll just go with the default message. Now the git pull is done. We'll see if Mary's changes in there. And there it is. She added that new word there. On Mary's laptop, she's seeing the change that she made, but not yet the change that Joe made. Now he can do the push. Mary wants to see the changes that Joe made. She needs to do git pull. And in the meantime, she hasn't made any new work, so the pull just works. Let's see what version of the file Mary sees now, and it should look the same as Joe's. There it is there. Okay, let's just recap what we just saw. So at the start of this timeline, Joe and Mary were both at the second commit. They're in sync. And Mary does some work and creates commit number 3. Joe does some work, not realizing Mary's working around the same time, and does commit number 4. Mary pushes her work to GitHub. Joe tries to push his work, gets that error. That's why I've got the cross through there. Joe has to pull Mary's work to his laptop, where Git will automatically merge the 2 team members' work together, creating another commit, which I'm just calling commit number 5. And Joe will push that commit to GitHub. Mary pulls that commit, and now the team are in sync. The next demo starts off similar. So Mary goes back and does some more work on the file. Around the same time, Joe is also editing that same file, but this time, Joe and Mary are editing the same line on the file. And this is going to create a more complex problem. By the way, they don't really need to be working at exactly the same time. They just need to both be working off the same base commit. That'll set up this problem. Mary commits her work and pushes to GitHub. No problem so far. Joe commits, tries to push like last demo. Again, there's a problem. But this time, when he pulls Mary's work to his laptop, there's a conflict. Joe's going to have to manually resolve that conflict. Now, usually you discuss it with your team members because you've both edited the same line of a file, right? You've got to decide which of the edits you actually want to keep. Git can't make that decision for you. Joe manually edits that in the file. Now he can commit his work, push the edits back to GitHub. Mary can pull those edits and the team will be in sync. So let's say that Mary's doing some work here and she says, I don't like our cool group project. I'm going to change that to our excellent group project. Saves the work. Joe also doesn't like the word cool and he decides to change that to brilliant. And let's say Mary decides to commit and push first. Mary pushes that to the repo. Joe's going to do the same thing. He doesn't see any problems yet. He tries to push. And straight away Git says, nah, you can't do a push, Joe. Since the last time you pulled the code, someone else has made some changes. You're going to have to pull that code. And this is where the team discovers that there's a conflict. We can't do an automatic merge here. You've got to have a meeting now and decide which of these changes that you both made to the same part of the file you want to keep. Let's refresh Joe's view of this file, and you'll see that Git does something interesting inside the file. This is what's required to point out wherever in the file this conflict has happened. In this case, there's just one line. It's the title line inside the head of our web page. So the team get on the phone. We've got a conflict here. We need to decide which one we're going to go with. And they end up deciding, yep, excellent's going to work better. In VS Code, we can just say, accept the incoming change. If you're not using VS Code, you may not see this, and you've just got to get in and edit this yourself. Let's say they decide we're going to go with Mary's chain. On Joe's machine, that's the incoming change. I'm just going to click that. I'm going to save that on Joe's machine. Now everyone's just back to normal Git flow again. Joe commits that change and push that for the rest of the team to get. Still on the phone with the rest of the team. Okay, everyone, pull that change. We've fixed it up. There it is. So we can see that all of the team members have got the same version of the file. Conflict's gone away. We're back to normal. Let's just recap what we saw in the demo. So Joe and Mary both start on what I'm calling commit number 5. They both did some work around the same time, and now they're working on the same line in the same file. That's why I've colored those work timelines in red. We're setting up a problem here. Mary makes commit number 6. Joe makes commit number 7. Mary pushes her commit. No problem so far, because GitHub doesn't know what Joe's doing yet. Joe tries to push his commit. GitHub says, no, you've got to attempt to pull Mary's work. But when Joe pulls Mary's work, Git realizes that there is a conflict, and Joe will need to resolve that conflict. Joe resolves the conflict. That sets up a new commit. This is just a merge commit happening automatically. Joe pushes that work to GitHub. Mary pulls that work from GitHub, and the team are in sync. I just want to wrap up the lecture by highlighting 2 of the best practices suggestions that we made in the Git Basics demo lecture. They are that a team agree on a workflow that they're going to use, and also that you learn Git as a team and try to recreate the situations that you saw in the video. And by working through these scenarios and solving the problems that come up, you'll learn about Git, but more importantly, you'll learn as a team, and you'll be able to figure out exactly how you want to handle things throughout the rest of the semester.